so make sure you go ahead and get the chapter written down and the objectives. We're going to learn about a new piece of the circle today called a chord, and then we're going to be talking about arcs again, which we talked about a few chapters ago. All right, so here's our definition of a chord. It is a segment with endpoints on the circle. It can be anywhere inside your circle as long as its endpoints are on the circle. So if you notice the second circle right here, what line is drawn in there? The diameter. So a diameter is a type of chord. Okay? Its endpoints touch the circle. And on the left, here's another example. It's not a diameter. It's definitely not a radius. But its endpoints touch the circle, so we call it a chord. We've got 3 properties that we're going to be talking about that involve chords. Okay, so I want you to go ahead and get these properties copied down. And they tell us that in a circle or in congruent circles. So we could be talking about just one circle, or I could be comparing 2 circles that I know are congruent. I know they're the same. If I know these things, then I know congruent chords have congruent arcs. So if I've got a chord and I know the length of it is the same as a different chord, then the arc that is created by that chord has to be the same as well. The second one talks about if you have congruent arcs. So if you have 2 arcs, you know they're the same measure, then they have congruent central angles. Central angle is something that we didn't mention during our bell work, but do you remember what it is? Good. Okay, so it's an angle that's created by the center of your circle. So in these 2 circles down here, a central angle could be here or here. It's created by the center of that circle. So if you know the arcs are the same, then you know the central angles are the same. And the last property we know says that congruent central angles have congruent chords. So if you know the central angles are the same, which are these red lines that I drew in here, then you know the chords that made them are the same length. So once you get those properties written down, go ahead and draw the 2 circles. And what we're going to do is list everything that we know is congruent in this picture. Oh, I think that's Miss Hodges. Mine's right here. Okay, so let's look at this example down here. What we know is that the circles are congruent, okay? They've also told me that angle O and angle P are congruent. Those are my central angles, angle O, angle P, that I drew with the red arc. So if we know those are congruent, based on our properties, what else do you know would be congruent in my circle? Good. And what are KR and TS? Arcs, okay? So she's talking about from K to R. Do you remember what symbol we put with arc? How we knew it wasn't, yeah, an arc and not a line, we put a little arc above it. So we know that KR is congruent to TS. Awesome. What else do you know? Yep. Yeah, very good point. Now here, we don't really have another way to say it because we don't have a point down here, but we could be talking about KR the other way. So we would say arc KR is congruent to arc TS. You're going to have one on your homework tonight that it's kind of like this. You're going to have two arcs that look the same, but one way you're talking about the smaller arc, and one way you're talking about the larger one. Good, let's keep going. Yeah. KOR and TPS. And you're talking about the angle. Good, and that's a different way to say angle O is congruent to angle P. Okay, so which chord did you say? Okay, so I'm going to draw in the chord from K to R. So we could say that that chord, KR, is congruent to this one, TS. And a chord is just a line segment. So we're just going to put the line right above it. Okay, there's a few more things that are going to be congruent. What about the radius? Yeah, we've got some radii going on that we know are going to be congruent. Is that what you were going to say? No. Okay, we'll come to you in a second. So here we've got KO in the circle on the left. What would that be congruent to in the circle on the right? TP. And actually we can keep going because every radius should be the same length. So that should also be congruent to OR because that's also a radius. And that's also congruent to what? PS. Every radius is going to be the same length, no matter where you draw it, no matter what circle it's on. Okay. Angle O is congruent to angle P. That's what we started with, though. Yep. Good. So I think we got them. So if you know you have congruent circles, the radii are going to be the same. The arcs are going to be the same. The central angles are going to be the same, and the chord is going to be the same. Okay. So you're going to have one on your homework tonight where you get two circles. You're just going to list everything that you know is congruent. Okay. All right. So we've got some more properties that we're going to look at. And these two pictures should be pictures that you cut out. So we've got some if-then statements that we're going to look at. And if you remember back to way at the beginning last semester, we spent a whole chapter talking about these if-then statements. So the first one says, if chords are equidistant from the center, then they are congruent. That's what's going to go in the blank. I'm just going to use our congruent symbol. We can say that the other way as well. So if chords are congruent, then they are equidistant from the center. So we're saying the same thing, we're just reversing the order of it. So if I know chords are the same distance from the center, then I know they're congruent. And you can go the other way as well. If you know they're congruent, then they have to be equidistant from the center. So what we did is we wrote the converse of that if-then statement, which if you remember back to last semester, that's when we switched the hypothesis and the conclusion. So go ahead and look at the first picture up here. It should be the circle that you have where the distance is from the center is 9 units. And you know one length here is going to be 12.5. If you notice, what we're doing is we're trying to solve for A, which is the length of this chord. So let's look at the first property that you wrote down. It says if chords are equidistant from the center. So let's stop there. Notice we have two chords going on. I'll put them in red. Here's a chord, and here's a chord. Are they equidistant from the center? Yeah, they are. They are 9 units from the center. So since we know they're the same distance from the center, what do we know about the chords? They're congruent. How long is the chord on the bottom? And how'd you know it was 25? Good. Notice it has the like signs here. If that piece is 12.5, so is that piece. So the entire thing should be 25. So what does A have to equal? 25. They have to be congruent. Okay, now the second circle that's drawn is showing you the second property that you wrote down. So it says if chords are congruent, then they have to be equidistant from the center. So if you look down here, do you know these chords are congruent? How do you know? Okay, these segments, 18 plus 18, are going to add up to be 36, which is the same length as the other chord. Now, the chord on the top is 16 units from the center. So what does the distance have to be for x? 16. It's got to be the same. Really no arithmetic involved in these. You just kind of have to look at the circle and examine the lengths of the chords and the distance from the center. Okay, questions so far? All right, so we've got 2 more properties to look at, and we'll do a few more examples. These properties are talking about diameters inside of our circle. So the first one says if a diameter is perpendicular to a chord, then it bisects it. So I'm going to put in that symbol for perpendicular, which kind of looks like that upside down T. If you need to write in parentheses next to it that means perpendicular, that's not a bad idea. So if a diameter is perpendicular to a chord, then it bisects it. And what does bisect mean? Cuts it in half. And it makes a 90-degree angle. That's what it means for it to be perpendicular. Good. So now we're going to say that the other way around for our second property. So we're going to say if a diameter bisects a chord, then it is perpendicular. So just like the last one, you can say it either way. If it bisects a chord, then it is perpendicular. So go ahead and draw that picture. And what we're going to do is kind of go through 2 different scenarios. First, we're going to say what's going to happen if we know AB equals BC. We're going to say what would happen there. And then we're going to say it the other way around. What happens if we know AC is perpendicular to DB? So the first one that says if AB equals BC. So what I'm going to do is put in my like signs in there to show that they're congruent. If that's true, then what do you know? What else do you know in the picture? I know right now that it bisects AC. So what does that tell me about maybe an angle that they create? Then they're perpendicular. So then I know that DB is perpendicular to AC. So what it told me when it said AB is equal to BC, that told me that the diameter bisected a chord. And my property says if that happens, then it's got to be perpendicular. Okay, now we're going to say it the other way around. If AC is perpendicular to DB, so that tells me that there's a right angle. So that would be the first one. I know the diameter is perpendicular to a chord. Then what do I know? AB equals BC. So just like the last property, you can say it either way. So if a diameter is perpendicular to a chord, then it has to bisect it. And if it bisects a chord, then it has to be perpendicular. Okay, so we're going to look at our last two examples, and we're going to use the properties that we've talked about today to help us solve for a missing length inside of our circle. Now, what I hope you notice from these examples and then what you're going to see tonight on your homework is we're going to be creating right triangles inside of a circle. And that should give you a hint on how you're going to solve for the missing lengths. So on the first one, we're trying to solve for length R right here. What is that line inside of my circle? What would we call that line? The radius. It's from the center to the edge of my circle. What is this line that is 14 centimeters? What would you call that? A chord, because both of its endpoints lie on the circle. All right, what are some ideas here? How do you think we could solve for the length of the radius? Emily, what do you think? Awesome. So we need to use Pythagorean theorem. We've got a right triangle with one missing side. We usually use Pythagorean theorem to solve that. How did you know that we need to cut 14 in 2 to get that length as 7? And I just want half of it. So if I cut that in half, then I know I have 2 equal segments that are 7 centimeters long. So when we do our Pythagorean theorem, are you solving for a leg or a hypotenuse? Hypotenuse. So we're going to have 7 squared plus 3 squared equals r squared. So I'm going to give you guys just a second to go ahead and solve your Pythagorean theorem and get the length of the radius. If you have to round, let's go ahead and round to the nearest tenth. How did you get r by itself? Square root it. So square root of 58. Josh, what did you get? I saw yours. 7.6 is about the length of my radius. All right, let's look at the second one. It's the last one we're going to do. Notice we've got a chord, And we know that it is cut into 2 equal segments. So it's been bisected. Okay? What's the entire length of the chord? 22. How do you think we're going to solve for y this time? Probably Pythagorean theorem. Do we know it's a right triangle? How do we know? Good. It bisected the chord. This length y bisected the chord, so it's got to be perpendicular. Okay, that's what my property told me. So we're going to use Pythagorean theorem again to solve for y. Which one is your hypotenuse? 15. So we've got 11 squared plus y squared equals 15 squared. Again, I'll give you a second to finish that one. And round to the nearest tenth again. All right, y is about how long? 10.2. Alrighty, so your homework tonight is going to be a mix of a worksheet and out of the book. I'll hand out the worksheets in just a second. Tonight you are only supposed to do the front page of the worksheet. You will do the back page of the worksheet tomorrow when we finish 11.2.